Hi, my name is Sam Markstepp, and today I will be discussing how certain colors seem to appear neon and much brighter than other colors under a blacklight. Before we look at the colors, it is important to understand what a blacklight is and how it works. When you turn a blacklight on in a dark room, you will see a purplish glow. What you cannot see is the ultraviolet light that the bulb is also producing. The reason we cannot see the ultraviolet light is because our eyes can only see visible light in a spectrum ranging from red to violet. Above violet is the ultraviolet light we are unable to see. UV light is an electromagnetic radiation and with a wavelength shorter than that of visible light. Black lights are specifically UVA lights, meaning ultraviolet type A lights. This means that they have a wavelength ranging from 400 nanometers to 315 nanometers. The entire range of UV light in general is from 400 nanometers to 10 nanometers. Okay, let's turn off the lights and see these black lights in action. As you can see, the black lights appear to give off a purple glow, as I said before. Now, seeing as the UVA light that is produced is invisible, the black light bulb is lined with phosphor, which becomes illuminated under UVA light. Phosphors are everywhere. They are naturally produced phosphors in our teeth and fingernails even. Now, things that really give off a neon glow in black lights are highlighters. This is because highlighters contain high levels of phosphor, which illuminates in a black light, obviously. Phosphor is a substance that exhibits a pretty distinct display of luminescence or phosphorescence. Okay, now, seeing as the highlighter contains high levels of phosphor, if I take this off and when I draw on this, it might not look good right now, but once I bring it a little closer, put the black light on it, you can see it's a pretty distinct difference from the glow it was before. Like, take the black light away, then bring it in front of it. Like, that is because once the UV light passes and reacts with the phosphors, they just create a luminescent glow. Now, you can find phosphors everywhere, all over my shirt there's little white dust particles that contain phosphors, and this is because phosphors are commonly found in various detergents and things of that nature. Now, there is something you need to account for when it comes to phosphors if you plan on using it for any type of art or anything. Once you draw it, it'll look nice at first, but if you look, like, this green right here is the exact same green as on these tubes right here. Now, like, if you look closely, it's not as bright as the tube is, and even though it's the same color, this picture appears to be faded. The reasoning is because it actually is faded. Many phosphors tend to gradually lose efficiency by several mechanisms. The activators can undergo a change of valence, usually which is oxidation. The crystal lattice degrees, atoms, often the activators, diffuse through the material. The surface undergoes chemical reactions with the environment, with consequent loss of efficiency or buildup. When this happens, there's just a loss of efficiency or buildup of a layer absorbing either the exciting or the radiated energy. Electroluminescent devices degrade in dependence on frequency of driving current in the luminescent level. Moisture also impairs the phosphor lifetime significantly as well. And seeing as we are in Florida, the moisture levels are pretty high, around this area. So the phosphors will just kind of degrade over time, and they won't appear as bright as they were. Okay, so I hope you have a pretty broad understanding of why things glow in a black light. Now, when you see it on money, or anything like that, I just hope you have a good understanding of how things glow in a black light. Thanks.